Okay, welcome back. So now we're going to have the last presentation with Devin Burns and David Henderson. And they're going to present something that I really like, because it's one of my favorite interview questions: how to report and collect data, test data from performance tests. And here we go.
Did you know that when it comes to load times, Yahoo saw nearly a 10% drop in traffic when they introduced a 400 millisecond delay into their page load times? Similarly, Amazon saw nearly a 1% drop in sales when they introduced 100 milliseconds worth of delay. Page load times cost real money and real traffic, so we need to keep them under control. Thank you all for your attention this afternoon, and to Google for letting us be here today. My name is David Henderson, and I'm a front-end developer. I can normally find working in C# and JavaScript. And today I'm going to give you a bit of background onto how client-side performance affects our users, some of the simple and easy things that we can do to actually fix that as developers and testers. And then a little bit later on, I'll be talking about the reporting aspects of the project that we put together.
I'm working on the web accessible parts of our application. Today I'm going to be talking about how we went about automating the process of collecting client-side performance data, and how this fits into our test and development cycle, as well as fitting it back into the business. We work for smartFOCUS Digital. We develop a suite of web-based software as a service marketing tools. Our software allows our customers to generate large, complex digital marketing campaigns and see the results of this. So the organizations that use our software tend to be fairly large and have a fairly large user base. And this user base uses our software to target their customer base. They do this by generating their creatives, either using our web-based editor or on their PC, and then uploading it into our system. It means that our users tend to use our application for hours on end. And unfortunately, they tend to be on the end of highly contended network connections. So we needed to have a look at how we could optimize our sites specifically for these users, and then go from there. So we needed to find tools so that we could do this, see our issues, and start setting a baseline so that we could go from here to here. And because our test strategy relies quite heavily on test automation, we needed to find a way that we could automate this process and do the reporting of it. So we needed to just work through the process and start recording all of this data. So I'm going to pass you on to Dave, who's going to explain the consequences of having a slow site.
So if you've got a slow site, there's some really quite easy things that you can do about it. And these slow sites, they tend to cause less user interaction, and these tend to lead to higher bounce rates. So if a user is dissatisfied with the load time on a site, they'll often use it for a little bit, get fed up, and then move away and find somewhere better. And this leads to high bounce rates. So as Dave mentioned earlier, we've got a pretty complex system with a large number of users. And they've often got slow shared connections. So we really need to optimize the product to make sure that these users are taken into account and it gives them a really good experience. Any content redundancies or page bloat within the site do slow down the user experience. So it takes longer to load, longer to get into a state where it's usable. And if you're using a product for a long period of your day, as it's kind of like your core business tool that you're using, you're going to get annoyed after a while, and you're going to get fed up. And we really don't want that. So we really need to look and see what kind of things we could do to get around this. Fortunately, there's some really easy things that we can do to make some quick wins to get rid of some of these some of these performance issues. We can do some compression, combining and minifying static content such as JavaScript, CSS files. And for each bit of content that we don't have to send back down to user, they can get it. It comes down quicker, and it doesn't have to go over our infrastructure or bandwidth. Caching is a really important thing to get right. If you don't get it right, the user's got to pull down the same content over and over again from the server. It takes time, takes bandwidth again. Going with this, HTTP requests can be a bit of a killer. On particularly bad connections with high latency, each extra HTTP request incurs a latency penalty. And also some browsers limit the number of concurrent connections, so this can be a real bottleneck. So if we can reduce the number of HTTP requests, all the better. Redundant scripts, CSS files, things that get included twice on your site. This is pretty easy to happen if you're running a really complex site where things kind of mesh together. You've got master pages and systems like that. So it's pretty easy to get duplicate scripts cropping up. So if we can pull them out, again, it's all better for the end user experience. And images, we've all had images where it's been using the wrong image type for the particular content that it's showing. So if you can look for that, get it right, again, it's less content that the user needs to download. Another tool we can use, spriting, putting together similar images into one large image that gets downloaded at the beginning of the page load, and then you can box it out using CSS to get the right content to show in that particular area. Again, reduces the connections, reduces the downloads, and can, again, be cached. So before we started this project, we didn't really have any metrics available to show the end user performance of our site. It's a large app, there's lots of data, so there's often some pain points and slow bits that we kept on getting user comments saying this bit's slow and it really used to be faster, which was often kind of came from where we made sequential additions to add new features to an area, and we didn't really think about the consequences when it came to user performance. So as a developer, when we used to tackle this, we did some development and couldn't really see the results of what we were doing. We could kind of rely on stopwatches and Firebug to actually see how long the request took, Firebug and Fiddler to actually look at the complexity of the page and see what requests were taking place, what content we're downloading. But we couldn't really get any consistency in that particular process. So we went out looking for tools to help us kind of optimize this, automate it, and make it a whole lot more consistent. So when we started looking at this issue, which was about a year ago now, there were two main tools available to us. There was AOL's page test, which you may have heard about, and there was also YSlow from Yahoo. We gave these tools a bit of an evaluation, and we found that YSlow kind of met our needs a little bit better. It's a bit easier to configure, and it provided all the data that we wanted. It also provides some really nice recommendations to improve the performance of your site. And as you can see up there on the right, it can provide some really nice reports. A bit of history about YSlow. It's a tool developed by Yahoo's exceptional performance team. They initially to help optimize their own suite of sites. It was then released as a free tool to the community. And basically, it's a basic Firefox plugin. It's hooked into Firebug. And it analyzes the page as you load it in the browser. So it looks at each of the components within the page and analyzes the size, the type, and also the caching things that go along with that, and then produces some really nice reports. So here are the actual lint rules that YSlow uses to make these recommendations. So as you can see, it's a pretty big list there, and it's pretty comprehensive. If you look a bit closer, you can see that there's some of the really easy wins that kind of provide maximum benefit for not very much work that we were talking about earlier. So YSlow does cover these things that we're looking into and can help us to monitor these things. So now that we know kind of what we're looking for, we need to find out where these things are occurring within our site, go forward and fix them, and then keep on monitoring the situation so we make sure that we don't get any regressions. So at this point in our story, we were kind of using YSlow as a kind of ad hoc manual testing tool. So say if I was doing some development work, I would take a baseline test with YSlow, save the report down to a PDF or something, do the development work to make them improvements to that particular area, and then run the YSlow tests again. And this would be a pretty manual process, and it would involve eyeballing the reports and trying to work out the differences. Now, there's problems with that. We didn't have any historical data. So yes, we had the before and after. But say we wanted to look and see how it was 2 months ago, we just wouldn't have that data available to us. So we didn't really get any consistency and feedback of those results. So this all took a lot of developer time to actually do that manual process. And as in many software houses, developer time and tester time is a really precious resource, and there's not a lot of it to go around. And in this environment, there's often a lot of pressure on the management teams and product owners to keep on shipping new features. And this can often detriment the testing of existing features and kind of the overall performance of a site. So we found that without the data to show performance issues within the site, where they are, and any optimizations that we make, the effects of these, we found it really hard to get development time kind of allocated to do this work. So we need to look into a better solution. So that, given Dave is our automation chief, he's now going to talk you through how we implemented the system, automated, and got it going.
So I'm going to start with your average dev and test cycle. You got your developers creating some production code with some units and integration tests, checking these in, continuous integration servers coming along, building it, testing it, the products being shipped to the testers who start exploring through the system and start feeding back any bugs back to the developers. Unfortunately, at no one point are we actively looking for any performance gains that we could be doing or seeing if there are any issues at all. So since we kind of started using YSlow as a manual process, we needed to see if we could automate this. And if we could automate this, could we log the results and then from there start reporting on them? So we started, we needed to set out some requirements. And from there, we could start doing everything. These are the requirements that we came up with. So we needed a system that was consistent. It needed to be run quite regularly against sequential builds and produce valid, comparable data. We needed a system that was automated. The less you have to babysit it or even just think about it, the more likely it's going to get run. This frees up any developer resource and any tester resource because it's being done. The system needed to be low maintenance. Once configured, again, it needed to be forgot about. This, again, frees up any tester and developer resource. And finally, we needed something that was fairly easy to analyze. This is probably the most important requirement that we came up with. It needed to be viewed by technical and non-technical users so that they could get a clear state of how the system is at that time. We also needed to be able to show long-term trends, such as page creep, where small incremental additions to a page suddenly make the page load a lot slower. So how do we go about doing this? Well, while we were doing a bit of research, we found that YSlow has a small hidden feature that it allows the reports to be sent out as a beacon request. This is a GET request where the report is put onto a query string and sent out to the beacon page. Beacon page then just parses this GET request and you can store the data in the database. So it's starting to show all the component sizes and everything that's in there. Unfortunately, while we were doing this, we also noticed that YSlow wasn't producing as much information through its beacon request as it was through the visible reports. So since YSlow is just a Firefox plugin, we downloaded the zip file, opened it up, and found the JavaScript that we needed to change slightly. So like we wanted to see the primed and unprimed cache size of components that were on the page. And then we just zipped it back up, created a brand new Firefox profile, and stored it and installed it on the Firefox profile and started going through everything. We then needed a way to start walking through the system. So since you can set YSlow to auto-run, that was our first step. That was our first step to just automating everything. We also needed a way that would be that we could just load pages, go to the page that we want, or like go through a number of pages or something, and record these measurements. Unfortunately, for our system, you can't just fire up a page, get the results, and let it die down, because we have log-on pages. So doing that, you just get the log-on page, and everything else you'll start getting access denied. So we needed another mechanism to start walking through the system. Since we rely quite heavily on Selenium for our testing, it was quite a natural choice. And since we write everything in C#, we just started running it through NUnit. So we'd fire up our test, and they'd start running, and we start collecting all the information from YSlow. So, but unfortunately, Selenium also has one small feature that is quite good if you're just wanting to test your average code. But for this, it's quite bad. Selenium blocks quite a few caching headers from going through. It's good if you just want to test your code quite regularly. But if you want to start seeing any of this caching information, you won't ever see it. So when we started running this quite regularly, we started getting false negatives because you couldn't get all the caching information. And then we started running this every 30 minutes against our test farm. The CIs would then push everything into our test farm when we start running it. We ran this quite regularly so that we could try remove any potential anomalous data coming into the system. And we did find quite a bit. Every so often there'd be one run and you get something that you weren't expecting. But if you ran it straight afterwards, everything would even out again. So here's a data flow of kind of how everything works. We start by getting a request ID out of the database. We pass in the page ID, the server name, the build number, and the date that things were run. And then we start running our tests. We're loading up Firefox, start walking through the pages. While we're walking through this, YSlow starts firing off its information, collecting all of this stuff. And then we have our beacon page that's starting to collect all this information, parsing it, and then pushing it down into our database. And so that we can now reference our YSlow data against our query, our request ID. And because everything's being collected, we can just always see builds against runs. The next thing that we started thinking about was, because we're collecting all this information, we're starting to see that pages are getting a lot smaller. Our timing's getting quicker to load things. So obviously the natural choice is, how long does a page actually take to load? But we also wanted other measurements, such as how long do dialogues take to load up? And since our system's quite complex, we have some Explorer views. So how long does a tree node take to expand? And things like that. And since we've already got the request ID, we just mapped it against that. So now we're starting to collect timing data of things loading against our YSlow data. And we're starting to collect lots and lots and lots of information quite consistently through quite a lot of number of runs. So I'm going to now pass you over to Dave, who's going to explain how we started reporting on this.
So we wanted our reporting to be pretty much visible to anyone within the company. And as we're a web-based company, really. We develop web solutions. It's the obvious choice. We make fairly heavy use of jQuery within our products. So we went out looking for something that could help us to do the reports. We found Flot, which is a really nice reporting plugin that kind of has leveraged its functionality to create these reports. It's a canvas-based plugin. So it works in most of the newer browsers. There's also a wrapper for IE that kind of helps it along the way a little bit. We have a C# backend and a SQL database. This then pulls the data from the database, transforms it into a JSON data set, which the browser then pulls down from a JSON web service as each page is requested. So then we pull it together in the browser in JavaScript, and we create the reports, as you can see at the top right there, using Flot. So if we take a look at the bottom of the two reports there, we've got the page score report. Now, the setup for this is we have the builds running along the x-axis. The vertical lines that you can see, each vertical line is a new numbered build. So those can happen fairly often, every couple of days or so, depending whereabouts within the iteration that we are. We internally run monthly iterations, so they're fairly rapid. And after we've done some of this performance work, we managed to get a regular kind of 4 days or so of performance work booked each month. So that's kind of the figures that we're working with when it comes to looking at the performance that we gain from this. The page score plot shows each of the YSlow metrics as a separate series, and also the run count, which is the aggregate number of times that the YSlow data has been gathered for this particular page. This plot is just for one page, and it is showing it against the build numbers. So if we actually now go and have a look at some of the data, if you see there, we're looking at the caching and expires headers YSlow metric, and around the 1.7 mark, just highlighted there, the big red bar, which is the beginning of the iteration, we did quite a lot of work to unify the way that our caching works, and this also included some work to combine the JavaScript sets. And you can see that we've got a huge leap between the build before it and that build, where that work came into effect, and it's been measured. And we can see those changes over time. So if we now look at the page size for the same data, you'll see it's pretty much the same setup with the vertical bars representing the builds. The builds are still along the x-axis. Along the y-axis, we've got the size of the particular measurements. We do have the total size of the page. That's the unprimed size. So that's the size that you'll download for the whole page if you're visiting it with an unprimed cache. We also have the prime total size, which is the third series down in blue there. So that's the prime size where you've got a full cache. We're visiting the page for a second time or subsequent times, and that will be the amount that you download in those situations. We also break down the individual components of the page that kind of make up these sizes, both in primed and unprimed cases. So you can actually see exactly what's going on the particular page. So if we look at the same section again, you can see that the primed total page size has dropped rather significantly as a result of the work. Now this kind of ties in with the caching score that increased in the YSlow plot. We made a conscious choice to target the primed page size. Now if you think back to when we're talking about our users, they're not really the type of users that use the site for once or twice, just visit the site and then leave it and never come back. They're working with it all their working day. So it's an obvious choice to get the caching right so that they download stuff once and it's done with. And this actually shows here where we've created these JavaScript sets. Yes, all of the JavaScript that's included in the set may not be used in that particular page, but they've downloaded it once and it's a kind of one-time hit. After that, they'll download a lot less data as they move through the site, and as the sets will be reused on different pages. As Dave mentioned earlier, we also take a fair amount of timing data in the system. This is, again, the same setup pretty much, apart from its time along the y-axis. The builds are the same. Each data point is a build, and that obviously comprises of the number of runs. Dave mentioned that we're taking them every 30 minutes or so. So there's actually quite a large amount of data. We do show the maximum, average, and minimum load times. And we also do the extra user actions that a user would usually complete whilst they're on the site, such as opening a dialog, expanding a tree view, something like that. And as you can see, there is actually rather a large spike just to the right of 1.8 there. This is kind of the reason why we have the maximum and minimums. It does let us kind of look at the data and kind of analyze it and see, okay, yeah, there's been a large spike here. This is something we need to investigate and see whether it's a continuous issue, that's a recurrent issue, or, as in most cases, it's probably something down to do with the server or the environment. For instance, we're a .NET shop, so when you update to a new build, it often takes time to compile, and that often shows through in these timing plots if it's the first thing that's been run. So yeah, that's the timing data as well. Now, from the ease of analysis requirements, it's all well and good to have the individual page plots. You can kind of see what's going on a page at a page level. But we needed to see the whole site at a higher level, so we could just take one look and go, this is what's going on with the site. It's particularly useful for managers, so they can kind of look down and go, yeah, this is what's going on. So we created the delta plot. Now this shows the change in total page size for all monitored pages on the same plot. So each series is a separate page. And there's approximately 30 or so pages on this particular plot. Now, as you can see, you can spot large changes in a single version for either a single page or for the whole site as a whole. So if we look at it here, you can see that we've done some work. I think that was removing some excess JavaScript across some include files or something like that, where the page size across the site just drops. And that's great. You can actually see exactly what's going on. And if for some reason we included JavaScripts or excess bloat across the whole site, we'd see that as a whole. You can also pick out large changes in individual pages. So you can see here we found an issue. It shows an issue whereby a single page has excess data, and it gives you a clue that you need to go and look a little bit deeper and see what's going on. And in this case, we did go forwards, and you can see in the next build, we've remedied the problem. And this kind of helps with the turnaround time, spotting these problems. If you can see after each build what's exactly happened on the site, you can correct it as soon as possible. Flot, the plugin, also provides some really nice hooks that we can use. We created it so that you can highlight a single series by clicking on either the legend title or actually on the particular series itself. Hovering over any particular data point shows the name of the series, the build number, and the date, so you can actually see exactly what the particular data point is for. And we also do zooming, so you can see what exactly is going on in a particular area, and you can delve right down into exactly what you're looking for. So that's the reporting section of the site. Dave's now going to talk a bit about how this kind of fits back into the development lifecycle that we had before and how it kind of augments it.
So if we go back to our initial dev test cycle, we now have an addition to that, where we're collecting performance data, and this is being fed back into the development team, but it's also being fed back into management team. So the operations teams can see what's happening, operations managers, and also to the development managers, because now performance is not really being seen as an afterthought. It's actually being seen as a continuous feature of our application. So they're starting to allocate time to actually fix these issues because they want our customers to have a very good user experience while working through everything. But that's all really nice, but we also thought, how could we start feeding this back into what our testers are doing? And so we went about creating a tester's heads-up display. It's an overlay that we put onto our website that pulls in a number of data sources so that while a like testers exploring through the system, they get to see what's actually some of the extra information. So our T.H.U.D is a Jetpack extension for Firefox. So it just pulls in everything and starts showing everything. Like for here, like Dave was saying earlier, we have JSON feeds for a number of things. This is pulling in the JSON feed for all our YSlow information. So while you're exploring through the system, you have that information right to hand, and you can see everything that's there. We also started pulling in feeds from our source repository and from our bug tracking software, so that it hopefully removes the hit and miss that can potentially happen with any manual testing. Because now testers, while they're doing their job, can see that this part of the page has changed. I'm going to concentrate just on that and start working through that. And that will hopefully potentially allow them to track bugs back to the commit that made them. So here we have our final test and development cycle. There's 3 feedback paths that are happening. We've got our initial one in the blue that's doing what most people tend to do. Plus we've got our performance information. This is being fed to the management and through to the developers, as well as now to the testers through their testers heads-up display. The testers are collecting quite a bit of information about the structure of the page, what changes have been made to it, and any previous bugs or features that have been added to it. And this is being fed back to them so that they can start finding bugs and feeding that back to the development team. So what's in it for the product owner now? Well, the product owner is starting to see the benefits of lots of information flowing around to different people. They can see when, if changes, or see the changes that are happening, both positively and negatively. And so now they can start allocating time to work on specific things, not just trying to give out features to our customers that they want, but we can also start allocating time to bugs that could potentially just be a quick fix, or bugs that are that have happened through regressions, and they'll be done a lot quicker. And because this performance data is now coming back to the product owner and they can see what's happening, it's a lot easier to justify any change, like time allocations that they start making.
So the question is now, where are we? We can now got a system where we can view historical data at a glance, and it makes it really easy to spot trends as they're happening, both with between individual builds, so the immediate changes, and also the long-term trends as they grow. We have seen up to an 85% decrease in prime page size as a result of this work, and this has gone forwards into the customers and actually makes their page load times quicker. So as you can see there, the prime page size has dropped. And these content improvements do move forwards into the infrastructure team, because the infrastructure team now have to spend less money on servers to actually support the same amount of content, bandwidth to actually serve it up, and that makes everyone happy. And in the end, if we get happy infrastructure team, happy developers, a happy support team because they're getting less queries, because obviously we're a software as a service company, so that any issues that our customers have, they come directly back to us, and that obviously costs money. And more importantly, we have happy customers. And happy customers mean they give better recommendations to potential new customers. So it's an all-round win. So in conclusion, we've kind of taken you today from where we were before, running ad hoc manual tests with no instrumentation or metrics available to us, through to a fully automated system that uses Selenium RC, NUnit, C# to actually automate the collection process, YSlow to gather the data and run the metrics and produce the recommendations. We've introduced a reporting portal based on C#, JSON, jQuery, and Flot that gives a free flow of the information that we need to help us fix the bugs, find them, analyze them, and actually get the resource allocations to do so. From a tester's point of view, we now have the T.H.U.D, which really makes it easy for the testers to examine the area that they're exploring at that point in time and get all the information that's relevant for them at that point in time without having to go off, do some context switches to actually go and find that data that they're after. It's right there for them, so it makes their lives a lot easier. We've seen the site improvements for our customers with the page size decreases and up to 85% in some cases. So that's a bit of a bonus all around. And yeah, we just had generally good feedback from our customers. There is a demo of the performance of the reporting portal with some test data available. That's at performance.smartfocusdigital.com. Urge you to go have a look, have a click around. And hopefully there's been something you can take away from this today, and you can help implement that at your own companies. Thank you. Are there any questions? Fair enough.
Try.
Yep.
Yeah. Do you mind to return to the graph with the timings?
Yep.
Oh, yes. There is one. I feel, maybe I'm wrong, but you guys seemed like heading totally wrong direction. No? We started up with a timing about 2 seconds.
Yep, it's got it.
Now we are about 5 seconds.
Yeah, that is actually an artifact of what we've done. The timings, these absolute timings have increased. Part of this issue is we don't actually model currently the customer connection as it actually is. We have the monitoring server sat right next to the test farm. So we don't see these latency delays or, in fact, the kind of throttle bandwidth that we'd actually see from a client site. And this is part of the future work that we want to do. We want to introduce some kind of simulation of this, this kind of throttling. And some of the changes that we made, like creating these JavaScript and CSS sets, they do mean increased downloads the first time you visit the site. And obviously that will be reflected in these timings. So we do need to do some work on this to actually make this a bit better, more representative. But on the other hand, it does show relative changes, which is why we still use it. So if we do see something that has increased markedly between two builds, we can then go and investigate it. So yeah, we know the shortcomings, but as long as we know them, we're okay with them. We're going to do that work.
Yes, but guys, I think you should probably stop fighting for page size and start fighting with
Yeah, we've just now completed all of the work that we've got to do with trying to get the right page size, the right caching, and all that for our customers. We haven't actively done anything for timings yet. That is our next goal, is to now start moving on to making things actually load faster. But there's a slight difference between actual speeds and perceived speeds, because you can make things look like they've loaded faster, but they actually haven't. They're still loading in the background. Where these are more taking into account everything being loaded rather than the actual perceived speed that's things happening. So it's trying to work out the right balance between the two of that. So.
And exact that point of view leads us to my other question, which is, do you have any formal requirements, especially built for performance?
We do now, in the last 6 months, but before then we didn't. It was like I said, for the initial development and test cycle, is that we develop, we test through the CI, we get some manual testers exploring through the system, finding bugs, passing that back to the developers. So we're continually adding to our feature set, but not actually looking at how the user experience is for being like, again, going back to the perceived speed, the page sizes, like, so is it downloading a meg when it should only be downloading, say, 100 kilobytes, and trying to work out that.
Yes, but you know what? 1802 thing.
Yeah.
Yes, that's some sort of catastrophic. Yes.
This is why I said we run this quite regularly, every 30 minutes, because we get these anomalous bits of data that suddenly just appear for no reason. And this could have just been the application pool resetting itself when the test started running.
So
it's got to recompile everything.
Yes, and right here we can start with one simple rule. No page can be loaded more than 10 seconds. Yes?
Yeah, and we do follow that one.
And which leads us to my third question. Is there any bugs in your bug system dedicated to only performance issues?
There are now.
Performance testing is still a testing, and it's still stuck to the full testing process. Find a bug, find something that not fit your, your rules, your baseline. So it's a bug. Go guys, go fix it.
No, we have had those, and I think I can go back to this, where we did have people saying, right, this is slow, fix it. So we'd only just concentrate on that one aspect. So say like the Explorer view, it would take, because it's all JavaScript, and you try to do this in Internet Explorer, things can take quite a while to actually start rendering and doing the reflow in the browser. So we'd start just concentrating on that. But that could have a potential knock-on effect somewhere else. And because we're not setting a baseline anywhere when we were doing our previous performance bugs, because we have been looking at things and just fixing them as customers have complained. But it was always as an afterthought, not actually setting an actual feature request. Is that we were just doing this hit and miss type effect of testing and just going, or developments, just going, yeah, I think it's faster. My stopwatch says it's a little bit faster, but my thumb could have been a lot quicker this time than the last time.
Then, if you have strong or not so strong requirements, saying, for example, no any page can be loaded more than 10 seconds. So it's very easy to create a bug if something goes wrong.
Yeah. But that's why if we go back to that, where we do have a 10-second requirement, and every time something's gone over 10 seconds, it's dropped down straight away, the next build, as you can see in the graph.
Yeah.
So we do have that now, but this has been our process of trying to go from, having all these issues and not being able to have a baseline to start with, because you need somewhere to show you where the issues are and then build from there.
And previously, monitoring that would have been very expensive, because we'd have obviously had to manually go to each page, time it. And given the number of builds and the quick turnaround we need with the monthly iterations, it just takes far too much time to do that. So we needed some way of actually gathering that data automatically.
Yes, it looks like a regression performance test.
Yeah.
Very nice. So I spare my other questions to talk about.
Hello.
Hello.
I'll talk softer. Apologies if this was already talked about it and you were talking about it. Do you have plans to open source your code? And if you do, what's your plan for doing so? The Selenium project would love to have your the changes that you made, and I'm sure that the WebDriver team would also love those.
Yeah, we do have plans.
I mean, the Selenium team. We're all one big team. We'd all love your patches.
Yeah, we do have plans to open source it. We just need to make sure that we haven't got any potential company things inside it. So we just need to do that, and then we're going to be open sourcing it.
I think, to be honest, the changes to the Selenium code was a 2-line comment out, where it was blocking those headers through.
Yeah, I imagine the more the awesomer bits are all your graphs and how you generated them.
Those are actually on the demo site. It's all in JS, so you.
Oh, that's right. It's all JavaScript. I can just nick it right now.
Yeah.
Nice. Very nice.
And
just change your copyright notice, and then
yeah.
you'll be
Well,
allowed to.
Flux you can get off Google Code, so the graphing utility.
Great. Thanks.
So, as far as I can tell, this only applies to Firefox?
The browser's doesn't really matter for us in this case, because we were just trying to set a baseline. Because other than timings, because reflow and things like that tend to work a lot better in Firefox, but page size is going to be the same if it's coming down in IE or if it's coming down in Safari or Firefox. So the browser was not really relevant.
Yeah, we'd rather have a consistent platform where we just get the same data every time rather than picking up multiple sources where you're not exactly sure what's going on, potentially. Mm-hmm. So it's hopefully about consistency. And also the fact that YSlow is a Firefox plugin, and is the easiest, cheapest method to actually achieving the end result.
The beaconing.
Yep.
I'm just wondering, does that all happen once the page is loaded?
Yeah, basically, once the page loads, YSlow creates a JavaScript image object, and it sets the source to the beacon page with the results appended to that. Okay. So it just inserts it right at the end. So then and then that gets logged by the page that's the target of that. If that makes sense.
Okay. Yeah, I was just wondering if it was running concurrently. It seemed like it could have a performance impact, but as long as
it measures everything. Collates the results and then pings it off. It's a pretty quick process. Okay.
And is that your beaconing receiver? Is that likely to be open sourced as well?
To be honest, it's just a standard C# page that pulls stuff out of the query string and shoves it into the database. So there's nothing immensely clever. Yeah, we'll see what we can do.
Well, I mean, it seems like it would be useful for anyone who's using YSlow at all to have.
Yeah, there are actually a couple of other projects that have sprung up since we started doing the work. There's a few things to look at. There's YSlow. It's a similar concept, but obviously it uses unmodified versions of YSlow. So it doesn't pull down quite as much data. It basically just pulls down the total YSlow score, the score for each of the YSlow rules, and the total page size. So we obviously added in the extra metrics in that are shown in the report, and those are extras to that. I think there's also Cesium.
Yeah, it's a Firefox tool, or it's a mini project that they're doing for Mozilla Labs. It's a bit of Python that just fires off a headless Firefox instance, collects all the information, and then dies. So, but if you have any form of state in your application, you can't really use it unless you've somehow got the cookie beforehand. Mm-hmm. And since we do a lot of marketing data, our data is very, very sensitive. So, like anything that appears to be like you trying to get into the system, we just close that logon, and you have to re-log onto the system. So the cookie becomes invalid and things like that, so that we can protect our users who are using their data, and so we can meet European data protection laws.
Okay. Well, thank you very much.
Yeah, thank you.
Very nice looking stuff.
And these graphs or the performance test is actually run on dev, right?
They're run against the test. Yeah, it's not production data we're running against. That's one of the other things that we're looking to do soon.
Because the company I work for, we had the same problem because our performance was going down in production and we didn't know how to performance test it.
Yeah.
But our dev wasn't the same as the production, so we didn't have the same server and the caching.
Yeah.
But to give us a pinpoint, we started the same thing, the same graphs, And that would give us if a picture was too big or some JavaScripting was done badly, stuff like that. But our problem was still that our production was never in dev. So we're like, if you did that performance testing, it would still be better in production.
So I think what you're kind of saying is that we don't do any load testing against the test farm at the minute, against the system that this is running against. So yeah, it would be good to get also a view of what the production servers are doing in the same way, because you get these tests, especially the timing tests.
Yeah, because actually there are like two different systems, right?
Yeah.
Because you don't have the same amount of servers going on dev that you have in production.
Yeah, from our situation, we try and keep them as similar as possible, with kind of as many resources as possible to kind of keep them kind of the same, really.
Thank you very much. I've been doing something very similar, and I just have a recommendation.
Yep.
Instead of doing some simulation for the actual loading times, I can recommend you look at Jiffy by whitepages.com.
Oh, right, yeah.
They actually measure the loading time by real users.
Right.
And I've plotted it also against this timeline, and it's really nice for instant feedback after release. Oh.
Yeah, so that's for a production system, isn't it? Yeah.
Yeah.
Cool.
Right.
More question? No.
Which one? That last one? That was Jiffy, I think. JIFFY, I think it is. Yeah.
All right. Thank you. Thank you very much.
Thank you.
So we're gonna